Hi all, welcome to the next topic of Unit 1 Input Output Instructions. So, the contents we are going to see about input output configuration and input output instructions. So, input output configuration, consider a computer with a keyboard and a printer. So, a computer is connected to a keyboard and a printer, one input device and one output device. So the input device is used to take the input from the user, whereas an output device is used to give the input to the user through an output device. So here the keyboard, the input device contains a transmitter interface which acts as an interface between the keyboard and the computer, and the output device has a receiver interface which acts as an interface between the computer and the output device. So each and every device has a register called input register and output register. So the input registers and output registers are an 8-bit registers which are capable of storing 8 bits of information. So whenever an information has to be taken as an input through the keyboard, when a user press a particular character, that character is converted into a binary form. The alphanumeric character is converted into a 8-bit format, and through the transmitter interface, the information from the keyboard is placed into a register called input register. And similarly, when an information from the computer has to be given as an output, then the information which is available in the accumulator register, the accumulator stores a particular information, and from the accumulator, 8 bits of information at a time is given as an output to the output register, input to the output register, and it is stored in the output register, and through a receiver interface, the 8 bits of information is given as an output through an output device such as a printer. So this is how the information is transmitted and received by input and output devices. So this input register is an 8-bit register and output register is an 8-bit register. So apart from this, we also have a flag for each register, which we call it as a input flag FGI, which is an input flag, and FGO for an output register, which is an output flag. These two flags are one bit flags which can be set to either 1 or 0. So whenever the input register, the keyboard sends an information through a transmitter interface to the input register, and whenever there is an information available in the input register, then FGI flag will be set to 1. So whenever the CPU or the computer finds that the FGI flag is set to 1, it means that there is an information present in the input register that has to be retrieved by the computer. So the information from the input register will be transferred into the accumulator register. So, and once the information is transferred, the FGI flag will be made to 0 again. So if FGI flag is 1, it means that there is an information present in the input register. If FGI is 0, it means that there is no information present in the input register. Similarly, at the receiver side, whenever the accumulator has an information available that has to be given as an output, it first checks the flag bit FGO. So whenever the output register doesn't have any information present in it, so the FGI flag will be 1. So this is the reverse of input register FGI. FGO works in reverse of FGI. So whenever FGO is 1, which means that the output register is free. So the accumulator will transfer 8 bits of information into the output register, and it sets the FGO flag to 0. So if the FGO flag is set to 0, which means there is an information available in the output register. So whenever there is an information available, that information will be transmitted through the receiver interface, sent to the through the receiver interface to the output device such as a printer. So until the information from the output register is printed by the printer, the FGO flag will be set to 0. Once the information is given as an output, the FGO flag will be made to 1 again. So this is how an input-output interface works. So there are two registers that communicate with these two registers, input and output, communicate with the communication interface and with the accumulator register in parallel. The transmitter interface receives the serial information from the keyboard and transmit it to the input register. The receiver interface receives the information from the output register and sends to the printer serially. So the input register holds 8 bit of information and 1 bit input flag FGI is set to 1 when the new information is available in the input register, and it is clear to 0 when the information is accepted by the computer. So if you see the process of information transfer, initially the input flag will be 0 when there is no information available in the input register. Whenever a key is pressed in the keyboard, the 8-bit alphanumeric code will be shifted into the input register and FGA bit will be set to 1. So the computer will keep on checking the flag bit. Whenever it sees that FGA flag is set to 1, it means it transfers the information from the input register into the accumulator. And once the transfer is done, the FGA will be cleared to 0 again. So once the FGA is cleared, then the new information can be shifted into the input register by pressing one more alphabet or one more key in the keyboard. When you look at the output register, it works similar to the input register but in a reverse direction. So if you see the process of information transfer, initially output flag FGO is set to 1, and when the computer checks this flag bit whenever it wants to give an output to the output device. So if it is 1, the information will be transferred from the accumulator to the output register, and it keeps the flag bit to 0. The output device prints the corresponding character, and when the operation is completed, it sets the FGO back to 1. Next, coming to the input-output instructions. So the input-output instructions provides a means of communication between your computer system and input-output peripherals. So the input-output instructions enable the data transfer from and to the input-output devices like your keyboard, monitor, printer, etc. So with the help of input-output instructions, the computer receives the data input from the user and sends the output to the users. These instructions they act as a communication interface between the CPU and the peripheral devices of the system. So when you compare it with the register reference instructions, the input output instructions also does not require a memory location. So instead of 0 to 11 bits, they can be used here to specify the particular input output operation. If you see the instruction format of the input output instructions, the opcode is the 1111111 similar to your register reference, but the I bit is going to differ. In case of register reference, the I bit is 0, but in case of an input output instructions, the I bit is going to be 1. So the overall opcode for input output instruction is 1111. So this entire thing is said to be called as an opcode. So the input output instructions, they have an opcode of 1111 and they are recognized by a control D7. The decoder output is D7 and I bit is going to be 1. And the execution of these instructions also starts at timing signal T3. So each control function, it needs a Boolean relation. So the Boolean relation for these instructions are D7, I and T3. So D7 is the decoder input, I represents the addressing mode and T3 is the clock cycle which starts the execution of that particular instruction. In case of register reference, the Boolean relation is D7 I dash T3 because I is going to be 0 in that case. So here I is the 1. So it is represented as I. So this Boolean relation, it is by convenience we call it as small p. So if you see the list of input output instructions, these are all the instructions. So but the last two instructions are with respect to the interrupts. So interrupt, what do you mean by interrupt is actually if you look at the computer, the execution, the speed of the computer or the CPU is very fast compared to the speed of the input output devices. So whenever the information is transferred from the say from the accumulator to the output register. So the output registers take some time to give the information to the output device. So the input output configuration is very slow. So in that case, rather than CPU waiting for the particular output to be given to the output device, the CPU, rather than wasting the CPU time, the CPU places the information into the output register and it will continue with the execution of the other programs. So whenever this output register has completed its task and whenever it is free, then the output register can take the next character from the computer or from the CPU, so that it can interrupt the particular computer by means of an interrupt enable flip flop. So similarly, the input device, whenever the printer has a character to input, it will place into the input register, and whenever it wants that particular information from the input register to be transferred to the computer, it can interrupt the computer through a flip flop called interrupt enable flip flop. So for these two instructions, I off and I on, these two instructions are used to set and clear the interrupt enable flip flop. So whenever IOF represents interrupt off. So when this interrupt enable flip flop is cleared to 0, whenever it is set to 0, it means that the interrupt is off, which means the input register or an output register, it cannot interrupt the computer at any point of time. So whenever this interrupt enable is set to 1, which means it is interrupt on, with the help of interrupt on instruction, it means that they can be the output register or the input register that can interrupt the computer at any point of time. So that is the use of I off and I on instructions. Let's see the input output instructions. The first instruction is INP, that is used to input the character. So whatever the 8-bit information present in the input register, it will be transferred into the accumulator, the 0 to 7 bits of the accumulator. As we know, accumulator register is a 16-bit register, whereas an input register is an 8-bit register. So the 0 to 8 bits of the input register, 0 to 7 bits of the input register are transferred to 0 to 7 bits of the accumulator. And the FGI flag, previously when there is an input available in the input register, FGI flag is 1. Now since the information is transferred, the FGI is cleared to 0. Next is the output instruction. So output register, so the information present in the accumulator, the 0 to 7 bits, are transferred into the output register by means of an out instruction. And once the information is transferred to the output register, previously the output flag is set to 1. Now since the output register has an information, it will be set to 0. Next instruction is SKI. We call it as skip on input flag, which means it is going to check the status of the input flag. If FGI flag is 1, then we are going to skip the next instruction in the program order. That is done by PC implies PC plus 1. In case of SKO, we call it as skip on output flag. So it is going to check the status of an output flag FGO, and if this condition is satisfied, if FGO is 1, then we are going to skip the next instruction in the program order by means of PC implies PC plus 1. And the last instructions are with respect to I on and I off, that is with respect to the interrupts. Whenever the interrupt enable is on, which means that The input output registers can interrupt the computer at any point of time. So you can enable the interrupt by setting interrupt enable flip flop to 1, and you can set off clear off the interrupts by setting by using IOF instruction, where the interrupt enable flip flop is clear to 0. So this is all about input output instructions. So I off, I on, interrupt on, SKO represents skip on flag output, SKI represents skip on flag input, out represents output the contents from an accumulator, whereas imp instruction is used to input a character to the accumulator. So we have seen all the different types of basic instructions. So these instructions are memory reference instructions. These set of instructions are register reference instructions, and these are input output instructions. All these instructions together we call them as a basic computer instructions. Thank you.